Very good afternoon to one and all. This is Dr. Pranadute, and today we are going to discuss about the concept of sedimentary geology. So, this is a part of your paper geochemistry and sedimentology. So, we already discussed about the okay. So, sedimentary geology is a concept. Sedimentary geology is a combination. Sedimentology plus stratigraphy is the sedimentary geology. Why we are talking about the stratigraphy? Because whatever the layers you can find in a deposition sequence, like you have Vindhyan, Kadapa, and all these mostly are the basins, and they stratigraphically deposited, and after the deposition stratigraphically deposited, going to they are going to given the idea about how they are looks like, or how they are respond to the any process. So now, what is the definition of stratigraphy? Sedimentology. Sedimentology is the study of process. Sedimentology is the study of process, that is the production, composition, transport, and deposition of the sediment. Sedimentology is the study of process, that is the production, composition, transport, and deposition of the sediment. Whereas stratigraphy is a study of responses. Stratigraphy is a study of responses, that is inferring the control on the spatial and temporal changes of strata. Exact process that created the rocks can't be known because only the other rocks are left, not the process. So, what is the difference between sedimentology and stratigraphy? So sedimentology is the study of process, how the process has been operating in that various part of the earth. Whereas stratigraphy is the study of responses. Stratigraphy is the study of responses, which is the known as the inferring the control on the spatial and temporal changes of the strata. Exact process that created the rocks can't be known because only the rocks are left, not the process. So sedimentation and sedimentary rock. So about the 75% of the rocks, about the 75% of the rocks exposed at the earth surface. About the most of the part which is you have seen on the the most of the part which you can see on the earth is mostly a sedimentary origin. Mostly a sedimentary origin. So how the sedimentary rocks are been, because the you can see that what is the process behind the sedimentary rock, what is the process behind the sedimentary rock. The sedimentary rock is formed by the weathering and erosion, weathering, transportation, this activity. So this activity cannot be happen or cannot be operated inside the crust. It mostly occurred in a superficial part. Okay, it mostly occur on a superficial part. So this is how you can why you can have a more sedimentary rock exposed on the earth. Okay. So are the reservoirs for fossil fuel, iron, aluminium, or and groundwater record the earth history. So most of the fossil you can also find. Then what is the sediment? So sediment is having a loose sediment is a loose solid particle and can be heterogeneous, biogenic, and chemical. So when we are talking about the sediment, when we are talking about the sediment, Sediment is nothing but a loose solid particle. Loose solid particle is known as the sediment. Okay. Then you have a terragenous sediment. Then you have a terragenous sediment. So terragenous sediment is a fragment from silicate. A terragenous sediment is a fragment from silicate which is having a igneous and metamorphics. Which having a igneous and uh, then you have a biogenic sediment. A biogenic sediment are those sediment which having a fossil, uh, which having a fossil and the chemical that is precipitate with the chemical sedimentary rock. Then you have evaporation that is precipitated and supersaturation in a closed basin. So you can classify the particle size. You can classify the particle size that is boulder more than 256 mm. Then cobalt that is a 64 to 256 mm. Then pebbles can have 2 to 64 mm. Then you can have a sand that is uh, 1 divided by 16 to 2 mm. Then you have a silt and clay. Then grain size and grain shape that is depend on transport media. Okay, transport media that is a river which having a pebble which is bounce on a river bottom and move in a traction and sealed clay suspended in a water column. So how the grain size and grain shape means you can have the sedimentary rock or you can have any grains. If you visited to the river, any river, you can find a different grains. You can find a different grains. So that grains are transported that grains are depending upon the size of that grain is depending upon the which transported media they have used, then distance from the parent rock, okay, then distance from the parent rock, then mineral hardness and consider the sorting. So the grain size and the grain shape, the two important parameter, grain size and grain shape, two important parameter depending upon the what is the transport media, whether it is a river, whether it is a glacial, whether it is a lake, whether it is a wind. So different transporting media giving you the different grain size. Also, among the transported media also means in river you can see that if the grain is coming from only the 2 kilometer, the size may be not finer. Okay, if the grain is only coming from the 2 kilometer, the grain size may not be that finer. But if your grain is coming from the 2 or more than 2 kilometer, that is a 5 kilometer and all, your grain size may be a different one. Your grain size may be a different one, means a more finer. So this is how the distance from the parent rock and transporting media will control the grain size parameter. Then mineral hardness. Then mineral hardness. The harder the parent rock, the longer it will be take to sediment to erode. Example, silicate are more resistant to weathering and erosion than feldspar. And this is why beaches are often comprises of sand, not feldspar rich sediment. Then the sorting. Sorting is a winds that sort well. Sorting is a winds that sort well. Glacier sort poorly. There is a large spread of grain size in glacial deposit. Then you have classification of sedimentary rock. Then you have classification of sedimentary rock. So you have a detrital sedimentary rock, that is a mudstone, sandstone, conglomerate, and breccias. Then you have a detrital sedimentary rock, that is a classification. This is based on the particle size, whereas this classification is based on the terragenous input. So all detrital rock are clastic. So what is the difference between clastic and non-clastic rock? A very basic difference. A clastic rock are those rock which is having the which transported from the by the mechanical process. What that mechanical process are? The mechanical process are The mechanical process are like you don't have a chemical involved in that process. Okay, means pure physical processes, like river can flow on the basis of their whatever the velocity they have and all. Then we have a different kind of sedimentary rocks. Okay, then we have a different sedimentary rocks. So all about, so already we discussed that 75% of the earth, 75% of the earth is made up of the sedimentary rock, is made up of the sedimentary rock, because on the ocean floor, you know that what is the highest percent of spear, or what kind of, you know, the 70 sorry 71% almost covered by the oceanic surface. So you have a more hydrosphere. So in ocean, the mostly the sediment can deposit it from the river when the river meet to the ocean, and that all are the sedimentary rocks. That all are the sedimentary rocks. So most of the part of the oceanic crust is having a sedimentary origin, because it act as a basin to take all the sediment from the ocean river. Then sandstone particle. Then sandstone particle. So 1 has to 16 to 2 in diameter is all are the sandstone particle. 1 1 has to 16, 1 divided by 16 to 2 in diameter is all are the sandstone. Then the practical uses of sandstone, there is a building and reservoir for the fossil fuel. There is a building and reservoir for fossil fuel and groundwater, conglomerate and breccias. Grain diameter that is larger than 2 is known as the conglomerate and breccia. How the conglomerate and breccia can be differentiated then? So conglomerate is having a rounded grain. Conglomerate is having a rounded grain, whereas breccia is having an angular grain. Conglomerate is having a rounded grain and breccia is having an angular grain. What type of sedimentary rock do geologists recognize? So geologists, what is the work of geologists? To recognize the rock also and to tell us what kind of processes they have followed. That is the two things geologists do in the field. So detrital sedimentary rocks, the detrital sedimentary rock is a plastic texture classified by size and shape. Conglomerate, breccia, and sandstone siltstone shape are common. Shape are common. Then you have a detrital sedimentary rock. Okay, so in detrital sedimentary rock, conglomerate, breccia, sandstone, siltstone shales are common. Then you have mudstone. Mudstone are more than half of all sedimentary rocks. Mudstone are more than half of all sedimentary rocks, which contain the smallest particle, which contain the smallest particle. Then you have an environment of deposition, that is lakes, lagoon, deep ocean basin, river floodplain. That is a mudstone is mostly deposited in lakes, lagoon, where you have a calm environment. Okay, mudstone cannot form where you have a very high energy environment. So it required very calm and steady environment to deposit this mudstone. Then environment of deposition, lakes, lagoon, deep ocean basins, river, floodplain, that all are the environment of deposition. Color varies from shale represent mineral composition. The practical uses of shale is bricks, ceramic, cement, and oil and shale. So that is the practical uses of shale. Then you have chemical sedimentary rock. Then you have a chemical sedimentary rock. So inorganic chemical sedimentary rock, that is a limestone. Inorganic chemical sedimentary rock, that is a limestone. Inorganic, the formation of this one, how it form oolitic limestone to time. Then you have a sediment and sedimentary rock. Then you have a sediment and sedimentary rock. The lithification, the lithification is mostly lithification is transforming sediment into the. So what is the lithification? Okay, now you have one term that always been used. The one term is always been used, that is a lithification. So what is the lithification actually? So lithification is nothing but a transformation. Lithification is what? Lithification is nothing but a transformation of sedimentary sediment. Okay, transformation of sediment into the sedimentary rock. Transformation of the sediment into the sedimentary rock is known as the lithification. So when you anyone is called you as what is the lithification? So lithification is involving all the lithification is involve all the concept of what compaction, cementation, transportation. All this will be covered by the lithification processes. So you have a compaction like reduction in pore space and volume, that is your compaction. Then you have a cementation, that is a what is the cementation? Cementation is reduction in pore space, reduction in pore space and increase in a mechanical strength. Then you have common cementing agent include the calcite, silica, iron oxide. So lithification is when you have a turning sediment into sedimentary rock, that is your lithification. Then we have a diagenesis. What is the diagenesis? Diagenesis is changes in a sediment due to the increased heat. Changes heat into the sedimentary. So that is your lithification. Then you have a diagenesis. On that you have a lithification. Okay. So lithification is a compaction plus cementation. Lithification is a compaction plus cementation. That is your lithification. Then diagenetic process. Then diagenetic process. So what is the diagenetic process? Diagenetic process by which the weight of the overlying material reduce the volume of sedimentary body. That is your diagenesis. So so cementation and recrystallization. What is the cementation and what is the recrystallization? Cementation is precipitation of dissolved iron in the pore space. So cementation is a precipitation of dissolved iron in the pore space. Then what is the different things like you have a calcium carbonate, silica, iron compound. Okay, so this is a some cement we have used. So if there is a iron, your rocks will be looks like a your rocks will be looks like a your what we can say the reddish color. If the silica is there, if the silica is there, your rock will be looks like your what we can say the white color. So depending upon the cement, what kind of cement they have been used, we can have a different kind of cementation material. Then we have a texture of rock. Then we have a texture of rock. So formed by the compaction and cementation of sediment particle, formed by the compaction and cementation of sediment particle, then recrystallization of a certain unstable mineral into the new, more stable mineral. This happens primarily in carbonate. When you start with the carbonate mud, heat it up, then cool it is form a larger grain. Then what is the sediment and sedimentary rocks? So sediment is what we are talking about already. So ice, water, wind can all transport particle of various size to another location. Then abrasion and rounding and sorting. So this is a different sediment and sedimentary rocks. So we have different type of sediment. We have different type of sediment. Like we have detritus sediment, chemical sediment, okay, oceanic sediment. Then you have a, so this is a different kind of sediment we have. Then how the, what is the history of sedimentary rock? What is the history of sedimentary rock? So sedimentary rock follow the law. So law of superposition, an important principle that is used to interpret sedimentary rock. It stated that younger rock are deposited at the top and older one at the bottom. So I already explained this concept to you, that what is the law of superposition. Law of superposition is nothing but the youngest is always on a top, whereas oldest always on a bottom. Obviously, when you have a basinal area, in basin, when the sediment coming from their catchment and all, they are deposited, the first rock is deposited at the bottom, whereas the later one will deposit it on the top. So like that you have a sequence, like that you have a sequence of different deposited rock. So this is how you can have a different kind of, this is how you can have a different kind of rocks in the depositional sequences. Then what is the reading the story in sedimentary rock? How you can reading the story? So you can determine the, in what environment, you can determine easily in what environment the rock has been deposited. So means you have a different environment, like marine environment, you have a continental environment. This is a two major type of environment. Again, in the this continental environment, you have a lake, you have a fluvial environment, you have alluvial environment, and deltatic environment, lagoonal, and all these are the part of this continental environment. Then in marine also you have a shale, neritic environment, deep shale. So this is a different kind of environment we have. So now what is the concept of reading the story in the sedimentary rock? The concept is, when you have a sediment and when you have a specific sequence, like a graded bedding, a fining upward, a coarsening upward, whatever the sequence you are looking for, so that sequence tell you the story about in what environment they are get deposited. Like you have something like delta is always having a fining upward or coarsening upward sequence. River is having a fining upward or at in self, but river is also having some different composition, like you have a at different at the point bar, different at the your, so different kind of situation, different kind of condition, different time frame give you the idea about in what environment they are get deposited. Okay, so once you have a set parameter of the so this is, so you have some set parameter, like the coarsening upward is only found in this environment, the graded bedding is only found in this environment. When you have cross bedding, means the change in the direction of the flow and all. So this is a set parameter. In addition to the basics of the this all the sedimentary processes, you can also apply your knowledge of basic and apply your some uh, additional input of yourself, that you can think about that how it can be happen, what is the different because you all, when you are visited to the field, you cannot get the ideal sequences. When you are going to the field, you cannot get the ideal sequences. So therefore you have to apply, so the, for the anomalous rocks and this one, so anomalous rocks and anomalous condition, you have to apply your knowledge in that way. That is how you can have a sedimentary unit. So this is a common geological environment we have. So we have a continental and transitional environment. What is the continental and transitional environment? You can have a continent at the side where we are all living. That is your continent. Then we have a transitional and marine environment. Then we have a transitional and marine environment. Then you have continental environment. Then you have continental environment. Then alluvial fan. When you have continental transitional marine environment, subduction zone. So what is subduction to zone? You know that the subduction zone are the zone where your one plate is undergoes to the another one. One plate is goes to the another one. That is your subduction zone. Then you have a lake, river, swamp, and cave deposit. You have a lake, river, swamp, and cave deposits. That is your this environment. Then what can you have? A desert deposition. That then what you have? A desert deposition. Then you have a lagoon environment. That is a continental shelf and deep marine deposition. Continental shelf and deep marine deposition. That is your continental shelf. So this is a different geological environment we have. In addition to this, also there is a different environment like you have a lake, lagoon, and all, and so there is a lots of environment which can proceed your sediment according to their climatic condition. So this is some of the location of subsurface evaporites. Then come to the sedimentary structure. What is the sediment? Is having a stratification in it. Sedimentary structure is having a stratification. Like sedimentary rocks are bedded or layered. Sedimentary rocks are bedded or layered because the agent of deposition carry different material at a different time. So sedimentary structure are the bedded or layered. So first property or first structure that is found or first things you have to study in the sedimentary unit is the stratification. What is the stratification? Stratification is nothing but a layering. Stratification is nothing but a layering of the rock strata. Stratification is nothing but a layering of the rock strata into the different units. So sedimentary rock are bedded. Sedimentary rocks are bedded or layered because the agent of deposition carry different material at the different times. Different kind of stratification are indicative of different environment of sedimentation. Then we have a beddings, sedimentary beddings. So bedding is the arrangement of sediment particle into the distinct layer. The sedimentary particle bedding is the arrangement of sediment particle into the distinct layer. There is a changes in sediment change bedding. There is a changes in sediment change bedding. Changes in transport energy changes bedding. Then you have a normally graded bedding. What is the normally graded bedding and how it is we can have? So normally graded bedding is a sedimentary layer. So normally graded bedding is sedimentary layer that is in which the particle size varies gradually with the coarsest particle at the bottom. Inversely graded bed finds at the bottom. So you have a normal graded bedding and inversely graded bedding. That is the two sequence we have. So I will explain you this concept in a using the whiteboard. Please. So I will explain you what is the exactly the graded beddings are. So now you can have this basin like structure. Okay, this is a two basin I will explain you. This one is a known as the this is a graded bedding. And this one is a inversely graded bedding. So graded bedding and inversely graded bedding. These are two different beddings we have. So in the graded bedding, what the things can be happen, like you know that there is a if there is any sequence or rock, or if you are having a lake or something like that, according to gravity condition, your boulder, the or the higher coarse sediment, you can say the coarse sediment rather than boulder, it may be some type or different coarse sand also, they are deposited first according to gravitational technique equation. Then you have a medium grade, then you have some medium grade, then you have a finer grade. Okay. So this is how you can have different grains. This is how you can have a different grains, like you have then a very small grain here. Okay. So this is now a gradation, like from coarsening to the fining. Same in reverse in this one, that is known as inversely. That is inverse means reverse graded bedding, that coarses at the top and finest at the bottom. In this sequence, the graded bedding, you have a coarse sediment, means you have a graded bedding means you have gradation. You have a gradation like coarse, medium, fine. So this is a gradation we have in this one. Okay. So this is now how this is what you can have a graded bedding like structure. This is how you can have a graded bedding like structure. Then so this is what I already suggest you. What is the graded bedding? Okay, from coarsening to fining of that is your graded bedding. Then the cross bedding. What is the cross bedding? Change in the river. River can change their path and something like that. That sedimentary layer deposited at an angle, that is known as the cross bedding. Then you have some surface sedimentary feature like ripple mark and mud crack. Ripple mark are small surface ridges produced when the water or wind flow over a sediment after the deposited. Mud cracks are occur. Mud cracks are occur when the occur on the top of the. Then development of the cross bedding. Development of the cross bedding. This is how your cross bedding will be developed. This is how your cross bedding will be developed. Then we have a asymmetric and symmetrical ripple. Then we have a symmetrical and asymmetrical ripple. So asymmetrical and symmetrical ripple is asymmetrical ripple when movement of the sand on water in a unidirection, means in one side only. When there is a two-side directional process, that is known as the symmetrical ripples. So this is how you can have a symmetrical and asymmetrical This is how you can have a symmetrical and asymmetrical cross bedding. Then formation of coal from the swamp deposit. Then we have a formation of swamp coal from the swamp deposit. So you know that coal is a sedimentary unit. A coal is a sedimentary unit. Core is a sediment unit which having a overlying marine sediment deposited during the rising sea level. Then you have overlying sediment bury lights. So coal is deposited in a swampy basin or basin mostly. Coal is deposited on a swampy basin mostly. So this is a different formation like you form. We will discuss this in a very in a separate lecture about how the coal is formed, how the oolite is formed, how the mud rack will form, and this one. So this is a sedimentary facies, and we will just overview the sedimentary facies. What is the sedimentary facies exactly? So sedimentary facies is the deposits of sediment that have physical distinctive physical, chemical, and biological attributes high energy deposit environment, which are existent to the finer grain sediment that are deposited in a water. Facies are typically recognized by grain size. Sedimentary facies are transgression sedimentary facies is a transgression which is nothing but the rise in a sea level relative to land, result in offshore facies being deposited over the near shore facies. Regression is fall in a sea level. So we are also called as a shoreline will be shifted to our land. That is a transgression. When the shoreline gets shifted towards the ocean, you have a landward migration of shoreline. That is, you have a landward migration of shoreline. This is graded breeding. So this is the overview. This is the overview of the sedimentary geology. What is the sedimentary geology all about? And on each on each what we can say the each topic you can have a separate lecture like how the coal is formed, how the oolite is formed, what is the facies, what is the depositional environment, what is the marine depositional environment. Each one is having some separate lecture. It requires separate lecture to explain because this all the topics cover a very large area, a large things. So this is what a sediment in a stream, sedimentary overview we study now. Okay, so this is all about the sedimentary sedimentary overview of sedimentary environment. You have this 10 MCQ question. So, what is the shale? Shale is refer to the rock formed from which size of the material, whether it is from sand size, plants remain, clay, mineral, and carbonate. What is the answer? You may know that the shale is nothing but the form by the in a calm environment, and it form a mud stone. Shale is formed from the a very finer sediment. So, what is the finer sediment? Sand is finer or clay is finer? That is, you have to decide which of the biochemical sedimentary rock, coal, shale, or conglomerate, and which one of the following does not associate with the sedimentary rock, fossil, and all. So this is also you can go and sort. Thank you for listening this one lecture. Hope you understand the concept of this one well. So thank you for listening. Thank you.